can just look up the common elements, right? Computation to actually find out the common elements, and then you will get your answer. Sure, this method works, but we can also optimize it. Let us see how. To find out an efficient solution to the problem, it requires a bit of a mathematics. So, when you need to find out all the multiples of the first array, right? And you want common multiples. So, what hint does that give you? Do you actually need to calculate all of the multiples of all the elements of the first array? No, right? Because you are interested in just the common multiples. So, that should help you eliminate some of the choices in the first place. So, instead of knowing all the multiples of all the elements, how about we calculate just the common multiples? So, in this case, you have 2 and 4. So, the common multiples of 2 and 4 would be 4, 8, 12, 16, and so on. You see that we have already eliminated half of the choices, right? Similarly, when you are calculating the factors of the second array, do you actually need to calculate all of the factors? You just need to find out the common factors, or rather, you just need to find out the common divisors, right? So, in this case, when you have your numbers like 16, 32, and 96, you can start to find out the integers which are common divisors. In this case, you see that 2 is a common divisor, 4 is a common divisor, 8 is a common divisor, and then 16 is a common divisor. Now, you do not need to calculate the rest of the elements, right? Because any element greater than 16 would not divide 16, right? So it won't be a factor. So you see, we have narrowed down this problem to this size. Now you can just look up the common elements, right? So in this case, you can see that 4, 8, and 16 are the common elements, and hence 3 is your answer. Now, based upon this analogy, you can come up with an approach. What you can do is, you can try to find out the lowest common multiples of the first array. So, the LCM of the first array would be 4. As you can see, 4 is the lowest common multiple. And going ahead, for the second array, what you can do is, you can find out the greatest common divisor, or the GCD. That is the highest number that will divide all of the elements in array number 2. So in this case, 16 is your GCD. So basically, when you have the LCM and the GCD, you simply need to find out the common multiples of LCM that also divides the GCD, right? So you can see that the multiples of LCM are 4, 8, 12, and 16. And out of these, the numbers that divide the GCD are 4, 8, and 16. And hence, you find 3 integers. And once again, 3 is your answer. Now, let us see how you can go about implementing it. To understand the dry run of the code, on the left side of your screen, I have the actual code to implement the solution. And on the right, I have the same sample test case that we were just discussing. So we pass in two parameters, the list A and list B. Next, we initialize the result variable to be 0. So right now, we assume that we don't have any such integers. Going ahead, we find the LCM of all of the elements of A. So when I run this LCM method, I would get the LCM of all the elements of the list A. In this case, the LCM would be 4. I am taking the help of a helper function getLCM. You can find the complete code in the description below. Then, moving ahead, I find out the GCD of all of the elements of the list B. So, when I find out the GCD, I would find that the greatest common divisor is 16.
As I'm in the midst of applying for residency right now, wish me luck, Grammarly has again been a lifesaver with my application.
Once again, I am using a helper function getGCD. You can find out its implementation using the link in the description below. So now I have got the LCM and the GCD. What we now need to do next is we just need to find out the multiples of LCM that also divide the GCD. How can we do that? Right now, the value of multiple is 0. So I start a while loop. Then I add one multiple of LCM. So the value of multiple becomes 4. I check if my GCD could be divided by the multiple. So 16 modulus 4 is 0. And hence I do a result plus plus. Since this is a while loop, I would go ahead and I will again add one of the multiples. So this time my multiple becomes 8. Once again, I check if my GCD can clearly divide my multiple. Since this is also equal to 0, I again increment the count of result. Moving on, the value of multiple again increases and it becomes 12. I would check if GCD modulus the multiple is 0. Since this is not true, I do not increase the result count. The while loop will run again, and this time the multiple value changes to 16. I again check if GCD modulus my multiple is 0. Since this is true, I would again increment my result count. So now this while loop has ended. And you can see that in my result variable, I have my answer. This
Taxes was waiting and wondering and worrying. Now Taxes is matching with a TurboTax expert who does everything for you.
So today I'm going to show you just use a different thing here. Everything in B, the number. So we are going to iterate for I in range from max A to min B, right? From max A to min B, and because the range function is exclusive of the second parameter, I'm going to say +1 so that it can include the actual min B value. All right, so at this point we can now, first we can assume that this number is accepted, that is a factor of the first array. The first array is a factor and the second array is a multiple. So we can say is factor multiple equal to true. But along the iteration, if we find out otherwise, we're going to set it to false. And at the end of the day, if we check this value, if it's ever false, then this item on the iteration will throw it out. We'll never add it up. So I'm going to start the first iteration. I'm going to say for
then the integer that we considered, which will be equal to the last element of first array. So a dot get, and the element will be size -1, which is the last element, and then take one variable as flag. We will assigning value to the flag later, but let's declare it here. Okay, so now what we have to do, we have to check while current factor is less than equals to the first element of second array, b dot get 0. If this is the condition, then what we have to do, first let's assign the value 0 to the flag, and now we have to loop through the first list for int I equals to 0, I less than a dot size and I plus plus. And what we have to do, we have to just check that if the current factor mod by a dot get I not equals to 0, then we have to assign the value of flag to 1, and then we have to break out from the loop. Now if flag equals to 0, then what we have to do, we have to just loop through the second list for int I equals to 0, I less than b dot size, and simply increment the I by 1. Now we have to check if the b dot get I mod by current factor not equals to 0. We have to again assign the value 1 to the flag and simply break through out from the loop. Now we have checked for the both the list. Now we have to first element of now we have to return the count. Element of satisfy, simply increment the count. Hey there YouTube, this is
Want to become
Ryan Miller
Nate Jones
Gina Costa
grabs his phone.
checks his notifications.
Hello, welcome to Mastering Java Lesson 6. What we're going to do here is learn about the enhanced for loop that's really tailor-made to help you search through arrays from beginning to end. Now, we've already learned how to loop through arrays. What we essentially do is set up a variable. We start it off at 0, and then we increment that variable, and we're accessing the elements of the array by using the index. And that's perfectly fine. But that kind of process is used so frequently in programming when you create an array and you search through the array or scan through it for something that they've actually created a loop in Java that does it much faster. So for instance, let's go ahead and create an array. We're going to call it, let's call it an integer array. And we're going to call it my name, Jason. The brackets mean it's an array like this. And inside of this guy, we'll just put some numbers. So 3, 4, 5, 6, 7, 8, 9, 10, or let's do it like this, 10, 11, and we'll close it off like this. So now we have an array. Now again, typically if we wanted to search through this guy, and let's say we wanted to print the array out to the screen, we would create a variable, set it off at 0, and then we would access JSON bracket variable starting at 0, and the loop would go through 0, 1, 2, 3, 4. Each time we go through the loop, we'd be putting an index in here so that we can access and print it out. And we've done that before many, many times. Now, the enhanced for loop is set to do this a lot easier. So instead of doing all of that stuff, keeping track of the index and all that stuff, inside of the for loop, just create an integer, and you can name this anything you want, but let's call it elements. Right now, we're not going to set it equal to 0 or anything like that. We're just going to do that. We're going to put a colon here. And then after that, we're going to put the name of the array that we want to search through. This time, the array is called JSON. So to make it more readable, I'll put the colon between like this. Now, this is a for loop, so we need to open a curly brace and hit enter. And now this effectively, without doing anything with array indexing, is automatically going to search from the very first element of the array that we specify here all the way to the very last element of the array specified here. And every time we go through the loop, the current value of the array that we're investigating or that we're looking at will be stored in this variable that we've declared inside the loop called element. That's why we have an integer out here, because these values are going to be stored into this variable temporarily as we go. So we can do something like system.out.println like that, and then we can just say element. That's it. Now what's happening here is basically this loop is saying, okay, start from the first element in this array, and then we go to the inside the loop and we print out that value. So as we go through, 3 is stored in the element variable, and then we print that guy out. Then the loop goes those because these
a certified project manager but aren't sure about the skills you need? The PMP certification
Trust me, you have 2 and 4. So, the common multiples of 2 and 4 would be 4, 8, 12, 16, and so on.
Hey, everybody, this is Paul. In this tutorial, I'll be showing you how to find the greatest common denominator by using the Euclidean algorithm. So for this first example, I've got the numbers 10 and 45, and the greatest common denominator is going to be the largest number that divides both 10 and 45 evenly. So in this case, it's going to be the number 5, but if we couldn't see that, we could use the Euclidean algorithm to find the same answer. So what we do is we take the larger of the two numbers, so in this case it's going to be 45, and then we set it equal to the smaller number times some number q plus some number r. So the q is how many times 10 goes into 45. The r is the remainder of that result. So for our case, it's going to be 45 is equal to 10 times 4 plus 5. 10 goes into 45 4 times with a remainder of 5. So the next step in all the remaining steps is we take the number that's in this position and we move it to where this number was on the left-hand side. And then we take our remainder and we move it to where this number was. And we just kind of follow this pattern all the way down until we get a remainder of 0. So for our case, we're just going to get rid of the 45 and move the 10 where the 45 was. And then the 5 goes where the 10 was. So now we're asking ourselves, 5 goes into 10 how many times? 2 times with a remainder of 0. So now that we have a remainder of 0, we simply look back at the previous remainder, and this is our greatest common denominator for the original two numbers. So let's try this for this bigger example here now. So we take the larger of the two numbers, 3,768, and set that equal to 1,701, the smaller number, times some number plus some remainder. Well, 1,701 goes into 3,768 2 times, with a remainder of 366. Now moving this to the left-hand side here, 1,701 is equal to 366, moving that over, times 4, and that's plus 237. So 366 goes into 1,701 4 times with a remainder of 237. Moving the 366 to the left-hand side now. 237 where the 366 was. So 237 goes into 366 1 time with a remainder of 129. 237, moving that to the left-hand side now. 129 goes where the 237 was. And 129 goes into 237 1 time with a remainder of 108. Moving the 129 to the left-hand side now. And the 108 to where the 129 was. 108 goes into 129 1 time with a remainder of 21. 108 is equal to moving the 21 over here. So 108 is equal to 21 times 5 plus 3. And then one last step here, moving the 21 to the left-hand side. 21, moving the 3 to where the 21 was. 3 divides 21, goes into 21 7 times with a remainder of 0. So now we just simply look back to our previous remainder, and this is the greatest common denominator of our original two numbers. So the greatest common denominator of 1,701 and 3,768 is the number 3. So you guys have an excellent day. Thank you for watching, and if you haven't already,
Here's how the average man's life would change if he never saw an ad again. Day 1.
You see that we have already eliminated half of the choices, right? Similarly, when you're calculating the factors of the second array, do you actually need to calculate all of the factors? You just need to find out the common factors, or rather, you just need to find out the common divisors, right? So, in this case, when you have your numbers like 16, 32, and 96, you can start to find out the integers which are common divisors. In this case, you see that 2 is a common divisor, 4 is a common divisor, 8 is a common divisor, and then 16 is a common divisor. Now, you do not need to calculate the rest of the elements, right? Because any element greater than 16 would not divide 16, right? So it won't be a factor. So you see, we have narrowed down this problem to this size. Now you can just look up the common elements, right? So in this case, you can see that 4, 8, and 16 are the common elements, and hence 3 is your answer. Now, based upon this analogy, you can come up with an approach. What you can do is, you can try to find out the lowest common multiples of the first array. So, the LCM of the first array would be 4. As you can see, 4 is the lowest common multiple. And going ahead, for the second array, what you can do is, you can find out the greatest common divisor, or the GCD. That is the highest number that will divide all of the elements in array number 2. So in this case, 16 is your GCD. So basically, when you have the LCM and the GCD, you simply need to find out the common multiples of LCM that also divides the GCD, right? So you can see that the multiples of LCM are 4, 8, 12, and 16.